Hi everyone, my name is Aiden and this is my final year project titled Leveraging Image Classification for Monkeypox and Skin Lesion Detection on a Mobile Application. So after obtaining a comprehensive open source image dataset comprising of multiple different skin lesion categories ranging from monkeypox, chickenpox, measles, cowpox, hand foot mouth disease, and even normal images, I developed a lightweight and efficient CNN model that is then hosted onto Google Cloud Platform to basically mitigate any kind of power consumption costs and storage costs as well as battery consumption costs, especially on lower end mobile devices. So this mobile application is coded in React Native and it's also hosted in Expo Go because this is just for demonstration purposes only. So this mobile application serves to enhance public knowledge on how to prevent getting infected by these skin lesion diseases and how to treat themselves at home if they were diagnosed with these skin lesion diseases as well. And it also aims to enhance public awareness as well. So the first function over here would be the map page over here, which allows the users to see any kind of nearby healthcare facilities within their vicinity, and they can also sort by the different categories up here. And this map page basically just serves to allow users to easily contact the nearby healthcare facilities for maybe like an appointment or an in-house diagnosis. So the map here is very interactive, and these cards here are sorted based on how close they are to the user's current location. And if they were to get lost, they can also just click on the card here to redirect them back to the healthcare facility on the map. They can use the call function over here to basically call the healthcare facility as well. And the next function of this mobile application is of course the classification function under the camera page over here. So users can use either their back camera like this or their front facing camera. Then they can also either take an image or they can choose an image from the gallery, and they can choose to also use the camera flash or not. So you can basically take images like this, and if there's no skin lesion diseases whatsoever, then the green bar will be shown on top. However, if let's say there is a skin lesion detected, the red bar will be showing on top, and it will redirect the user to the library page where it will show them prevention and care strategies on this respective skin lesion. So this library page here just serves to increase public knowledge on how to prevent getting infected and how to take care of themselves at home. Then it also shows like the definition of the skin lesion diseases and how it's transmitted, what are the symptoms, and also it shows the gallery for visual references of the skin lesion as well. Some of the skin lesion also has different stages which the users can basically map out based on the reference image over here. Then it also shows who is more at risk and what body parts are also more at risk for infection. And this goes for basically every single skin lesion. It's all very comprehensive. So it basically just serves to show how to educate the public on these matters. And they can also press on the links down here if they want to go to the certified sources and read up more about these skin lesions. Okay. So the final function of this mobile application is going to be the news page over here, which will show the news regarding these skin lesion categories within the last 30 days. Public health officials can use this to monitor any kind of outbreaks or trends, and users can basically hold down the article to look at the description, or they can also press on it to read up on the articles about these skin lesion categories. And that's it for a surface level explanation for this mobile application. Of course, there are going to be some limitations inside this project. For example, the model may be sensitive to non-skin lesions, such as pimples and moles, but in order to curb that, we can ask the user to segment out where are the moles or the pimples inside the images to prevent any kind of false positives. Next, the dataset size is actually quite small for this project. It was only about 1,314 images due to the limited number of images available online for open source datasets. So in order to curb this, we can collaborate with healthcare facilities and also source more images to increase the model's classification robustness. And finally, there are going to be some cold start inference delays for the cloud server when it comes to classifying the model, because if the cloud server is not used in some time, then it does require some time to warm up the model for it to be able to classify the image. So in order to prevent that, I think that we can just schedule some periodic warm-ups using APIs. So some recommendations can also be made for future phases of this mobile application, such as, for example, in order to increase the public awareness even more, we can integrate some dashboards for statistics that shows the infected skin lesions per location, and these data will also be sent straight to the government for data reporting as well. And if a skin lesion was detected in the camera page, instead of just redirecting the user to the library page for them to read up on how to take care of themselves at home, we can have a more focused view where it will show the nearest healthcare facilities and the directions to those facilities, as well as a more focused view on how to take care of themselves at home rather than the entire library page as shown earlier. And in order to increase public awareness even more, maybe we can integrate real-time geolocation hotspots, which highlights the high incidence areas for certain skin lesions on the map, and it also supports traceability for the public health authorities to easily track down these areas and maybe even diagnose treatments to these patients and reduce the cases in those areas as well. And that's it for my project. Thank you.